Okay, so example 5 is similar to the ones we did before, except the function now is a little bit more tedious, a little bit more difficult to work with. So I'm going to start it off with the f of x, which is 2x minus 5 to the power of 1/3 plus 1. And let's go ahead and find the first derivative. So f prime of x is equal to, using chain rule, we bring the power down, then we subtract 1 from the power, and we leave the inside part alone for now. Then when we're done, we multiply by the derivative of the inside. So this is technically 2/3, 2x minus 5 to the power of negative 2/3, which can be written as follows: 2/3, 2x minus 5 to the power of 2/3, like this. Okay, so now we need to ask what makes the derivative equal to 0 and what makes it undefined. So let's go ahead and write that down and solve. So unfortunately for this f prime, it cannot be equal to 0 because there's nothing on the numerator that can become 0. 2 is always going to be 2, so there is no solution here. However, it is possible for the derivative to be undefined. All we have to do is look at the 2x minus 5 and figure out what makes it 0. So the 2x minus 5 is going to be 0 when the 2x equals 5, so x is going to be basically 5/2. So we only have one critical number, and it came from the denominator for this one. So one critical number, let's go ahead and put it on the line and just kind of test if it's going to be a max or a min. Okay, so let's do that together. Here we go. Graph the line. So it seems like the function is going to be increasing before and after this 5/2. So the f of x is going to be increasing, and the f of x is going to be decreasing. I tested the value is 0 and 10 for this one, and both plug into the derivative, and they give us a positive result. That's why the function is going to be increasing. Okay, so let me do this arrows again. They look pretty ugly. So here's the first one, and here's the second one. So what does that mean about the 5/2? Unfortunately, 5/2 does not have a max or a minimum. So not max and not min. So not max and not min either. Okay, so just keep that in mind because it was not changing signs before and after. So this is neither max nor min. Okay, whatever. So where are the functions increasing, or is it decreasing? So the f of x is increasing on everything basically. However, when you write it down, you kind of want to write it like negative infinity to 5/2 and then 5/2 to infinity. You cannot write negative infinity, positive infinity, because technically at 5/2 you are not increasing or decreasing. You're just kind of standing still for a minute. And when is it decreasing? Well, it is not ever decreasing. This function is always going up. So no solution there. Okay, so that's the end of part 1. And part 2 said, what's the max and min? So part 2, we're going to say no max and no min. So no max and no min. Okay, so that puts us into part 3, where we have to find whether the function is concave up or down. And I'm going to find the derivative using this expression over here. So it's going to be a chain rule again, bring the power down, subtract by 1, and then, multiply by the derivative of the inside. So let's go ahead and write that down here. The third derivative is going to be what? The third part is going to have the second derivative. So the first derivative is equal to 2/3, and 2x minus 5 to the power of negative 2/3, right? I just copied it from the top to the bottom. And now I'm going to look for the second derivative. So there we go. We bring the power down and we subtract by 1, then we multiply by the derivative of the inside. So how much is that? The total here is going to be negative 8 over 9. And since the power is negative, let's just put the 2x minus 5 on the denominator and make it positive 5/3. So now the question is, what makes the f double prime equal to 0? What makes it undefined? Let's go ahead and write that down and answer those questions. So the f prime cannot be undefined because there's nothing on the numerator that can become 0. Negative 8 is always going to be negative 8. So again, no solution for that problem. Whereas for the undefined part, to become undefined, we need the denominator to be 0. And for that to be 0, we need 2x minus 5 to be 0. And this happens when x is equal to 5/2. We kind of did that problem earlier. And this time 5/2 is going to be the critical number for the second derivative, not the first derivative. So again, we'll make the line down here and investigate if this is an inflection point or not using the second derivative test. All right, let's go ahead and fill in the blanks and put all the numbers everywhere and see what happens. Okay, when I test the second derivative, I get a positive first and a negative after. So that means that the function is going to be concave up at first, and then it's going to be concave down afterwards, which makes, in fact, the 5/2 in this case become an inflection point. And remember in class we said you cannot have an inflection point that is a maximum or minimum. So if we look up backwards a little bit, the 5/2 was neither a maximum nor a minimum, but it turned out to be an inflection point. So that's great. That comes, that goes along with what we have learned previously. All right, so let's take all this information and write it down, and so that we can have it on the record. Okay, so the f of x is concave up on the interval from -infinity to 5/2, and it's concave down on the interval from 5/2 to forever. Concave down on the interval from 5/2 to infinity. Perfect. So, and that's the end of this part. Let me put a little box around this, and I believe the next part had told us to find the inflection point. So let's make a record of that too. So there's the inflection point at 5/2. Okay, and finally we're going to try to put the graph all together. So we'll do that over on this page. So here we go. Part 5 says graph the function f of x. So let's make the xy plane and put all the information together here on this page. So when I plug in 5/2 into the function, I get 1 at the end, 1, and so that's the reason why I'm putting the little dot right here at 1. Keep in mind this was the place where we have an inflection point, not a maximum or a minimum, so this is the place where the concavity is going to change. And remember, the function was always increasing, and it was concave up at first and concave down afterwards. So this is what the graph is pretty much going to look like, okay? So it's concave up for the first part, concave down afterwards, and at 5/2 it is going through an inflection point. So this right here is the inflection point. Let me make a inflection point. Okay, and the function is always going up. So if you have a little stick figure guy and he walks left to right, he's always going uphill. And perfect. That's all.